You need to learn this for your C2 exam. A geometric series starts with A, and then we multiply by R, then we multiply by R again, and we keep doing this all the way along. And let's do one more. And then we finish when we get to the nth term, AR to the n minus 1. Now the trick for this particular proof is to take every single term that we've just written down and multiply by R. Multiply everything by R. So that's going to give us this. RS equals AR plus AR squared plus AR cubed. And you can see all of the powers on the R's are going up by 1. So instead of n minus 1, that final one will be n. Now what we're going to do is do the first equation that we wrote minus the second equation that we wrote. So that gives us this minus this, S minus RS equals. Now we're going to do, well, let's just start writing them down. I've got A, where's my pointer? A plus AR squared plus AR cubed plus minus AR squared minus AR minus. So what's going to happen is that loads of these things are going to cancel out. I've got A, I've got AR, I've got AR squared, I've got a load more, and I've got AR to the n minus 1. But then I'm taking away AR, I'm taking away AR squared, I'm taking away AR cubed, I'm taking away all the way up to AR to the n. So this AR is going to be gone. This AR squared is going to be gone. In fact, everything's going to be gone. This AR to the n minus 1 is going to be gone with the one before there. This one will be gone with that one. Everything's going to be gone because these are cancelling like this. And the only things that get left are the A and the AR to the n, which is negative. Okay, I'm going to clear this and write it out again nicely so that you'll see what you would write in an exam, because you wouldn't write all those scribbles. So you'd write S equals A plus AR squared plus AR cubed plus AR to the n minus 1 to show that you know what a sum is. Then you'd show that you know the trick. AR plus AR squared plus AR cubed plus AR to the 4 plus AR to the n. Then you would, I forgot my R there. I didn't multiply the left-hand side by R. Then you would do S minus RS equals, and you would be able to go straight to this, A minus AR to the n. Then what we do now is pull out the common factor on the left and pull out the common factor on the right, and then we simply divide under. A over 1 minus R to the n. And that is your proof of the geometric series sum formula, sum of the first n terms. Now, if R is between minus 1 and 1, and n gets really big, then a special thing happens. R to the n gets really, really small. Imagine doing 0.1 to the power of 10. 0.1 times 0.1 times 0.1 times 0.10 times. It's going to be tiny. So, if we look at this formula, what we have is A over 1 minus R, 1 minus something tiny. 1 minus a tiny thing. Or 1 minus a tiny thing is basically 1. So what we have is A over 1 minus R. And that is the sum to infinity, where n has got so big it's getting towards infinity. And it's only going to happen that converges, that ends up going to something nice, if R is between minus 1 and 1, so that as n gets large, R to the n gets small.